Only us.
Yes.
What about the other people?
And Vuyo. And Babes is also asking questions.
Yeah, and the Moses guy, Mr. D Moses, yeah,
Yeah.
he's
And the other
also
one,
on.
I don't see him. I don't know if it's Julian or what. Jay something.
Don't be shy, guys. There's no stupid questions. There's no wrong answers. Don't be shy.
Yo.
You can see now yourself.
How's your screen looking, sister? Can you
Yeah,
see,
much
sis?
better.
Great.
Yes, I can see the question now. Clear.
But we can't hear you now, sir.
Also can't hear him. Just see the drawing.
I think his microphone is on mute. He must unmute himself. Oh, they.
All right, so this is on a building. Uh, uh, so we can take this as the destination or the ground. And then so that's the projectile. They said this is being projected horizontally. So this is what essentially we have here. So we have UH, right? They said mm, right, so the H is equal to 50 meters, right? And then UH is given. They said a cannon situated on a building. So that's the building, which is 50 meters high, fires a shell horizontally at a velocity of 280 meters per second. So UH is 280 meters per second. Right, so that is what we've been given, right? Yes. Are we in agreement here?
Agreed, sir.
Yes, sir.
Yes, sir.
Right. So we have here the range. Right, that's the range. This here is the maximum horizontal displacement or the range. Right. Yes. Right. This is all we've been given, essentially. Right. The question seems like it has multiple scenarios. So I'm going to leave it here. All right. But as far as the problem statements, this is the schematic illustration, right, as per the problem statement. Now let's look at A. All right. A, calculate the time taken until the velocity hits the ground. Not the velocity, until the shell hits the ground. I forgot something here. Vy. It's not Vy because that's the initial, so it's Uy. Right, Uy, what is it equal to? Right, the velocity in the y direction, or the velocity of the projectile in the vertical plane. What is it equal to at this point? If this is shot horizontally, right, and then falls to the ground or falls to its destination, what is Uy going to be equal to?
0 meters per second.
Yes, that's 0 meters per second. So we also essentially have that. Now the question is, calculate the time taken until the shell hits the ground. Right. Now, based on what we've been given, we have to think about the equation of motion that is going to be
So far,
most convenient for us to use here.
Final velocity minus initial velocity over acceleration. Can we use that one?
Final velocity minus
Initial velocity over acceleration.
There will be two unknowns there.
But okay. But don't we have the final velocity? Isn't that 0 and the initial velocity is 280?
The final velocity will be here at this point. So here you will have here we will have this. Right, so just before this hits the ground, that is where you will get your Vy. Your UH will be the same because there is no acceleration in the horizontal plane that is going to change your UH. So we do not have this. So if you use the equation that you refer to, will essentially have two unknowns. So we cannot use that one. It's essentially
Hello,
this.
sir. So
Yes.
so you said while the ball is up there, right? Initial velocity horizontal is 280 meters per second, right? Fine. And when the ball,
that is not what I said. That is what they said.
oh, okay, fine. But then now, when the ball, right, is near the ground, you said there, initial velocity horizontal is 280 meters per second.
Yes, it doesn't change.
So it didn't change.
Nope. So you have to think about what changes velocity. Acceleration.
Okay.
Right. Only
acceleration
changes velocity. Now, is the acceleration along the horizontal plane? All right, as far as the projectile, there's absolutely none. Right, there would have to be an external force in that direction for there to be acceleration, and there is no external force. Right, the only acceleration we have is the one due to gravity. Right, that is the one that is along the vertical plane. That is why from here, from the apex to the ground, right, the velocity of the cannon, it increases. Why? Because the velocity is being influenced along the vertical plane by gravitational acceleration. So because
Sure.
there is no acceleration influencing the velocity along the horizontal plane, it remains the same until just before it hits the ground.
Oh, okay. So basically, this ball it's only going downwards because of gravity.
Yes,
Yeah, it would have gone straight otherwise, but it's just that now gravity is now also acting on it. That's why it's going down also.
exactly.
So it's got like, so basically its movement has two components. It's got the component of that 280 meters per second, and also a component of negative 9.8 meters per second at the same time.
Okay, well, you didn't quite phrase it well, but yes, because I get what you mean.
Or let me say it's got two components of motion in two
Yes.
different dimensions, a
Yes,
horizontal one and a vertical one.
yes, that's the one. Yes,
Oh, okay.
that's the one. Right. Now, the equation of motion we can use here, there's two of them. The simplest one, I would say, is the one for displacement. Right. It will be this one. Sy, or let's just call it H. Right. H is equal to UT. Okay. Let me call it Sy for context. So displacement along the vertical plane or along the Y plane is equal to UT plus half GT squared. Right. Oh yes, I forgot here. For context, UY times T. Right. This one works perfectly. Right. It's also very short. Right. Why? Because we know the SY is the height. That's 50 meters. Right. UY is 0. Right. Times T. And then now we are looking at the projectile as it moves from the apex to the ground. Right? So motion is in the same direction as gravitational acceleration. So you take G as being positive. So this remains positive. Right? G is 9.8 times T squared. Right? Obviously, that's going to be equal to 0. Right? Half of 9.8 times half is 4.9. So essentially you will have 4.9 T squared is equal to 50. Right? And then you divide both sides by 4.9. That cancels. And T, remember we're looking for T, so you have to use the square root on both sides. This will be the square root of this. So the square root of 50 over 4.9 is 3,194 seconds. Right, so again, the same thing.
Yes, sir.
Right. Now, for the approach that one of you guys suggested, it would be a two-part approach. You would first have to calculate the final velocity. Right, so we can say here you would have to calculate the final velocity. So you would use Vy squared plus is equal to Uy squared plus 2Gh, let's say 2G Sy, right? And this would be Vy squared is equal to, we know that's equal to 0, plus, that's 2, 9,8, that's 50, right? And then Vy squared would be 2 times 9,8 times 50, which is 980. And then to get Vy, the final velocity, this would require that we use the square root on both sides. Square root of 980, which is, square root of this is 31,305 meters per second. All right, so to use the approach that one of you suggested, the first approach that one of you suggested, you'd first have to calculate the final velocity. And then after having calculated the final velocity, then you can use Vy is equal to Uy plus GT. Now you can use this. All right, Vy is 31,305. That's 0 plus that's 9,8 times t. All right, so essentially 9,8 t is equal to 31,305. Then you divide both sides by 9,8. Obviously that cancels. All right, meaning that cancels, meaning that t is equal to, so this divided by 9,8 gives us the same 3,194 seconds. Are we together? So obviously this is the much quicker approach, but if you happened to take this one, you'd have to calculate the final velocity first and then calculate the time using this one. Are we together here?
Yes, yes.
All right, so now I have a question before we move on to the other questions. If this were not projected, right, horizontally, right, say this was just dropped, right, from this point and it free falls to the ground, then you ask to calculate the time it takes for this to free fall from the top of this building to the ground. Right, would your approach be any different than the one we took here?
Hello, sir.
Yes.
I would use your equation on the left side of the screen. That initial velocity times time plus half gravity times time squared. I'd use that formula if it was just dropped straight down.
So your approach wouldn't be different. That's the point.
No.
Yes, that is correct. Why? Because even in that scenario, the initial velocity is still 0. So you take the very same approach. So taking the very same approach means that, right, the projectile or the object will take the same amount of time. Right? The object will take the same amount of time when it is projected, right? And it will take the same amount of time when it is just free falling. Because either way, when it is projected horizontally, right, along the vertical plane, only G has an influence, and there is no influence as far as acceleration along the horizontal plane. Similarly, when this is just free falling, right? As far as the time it takes for the object to move from the apex to the ground, whether it's free falling or it's been or it has been projected horizontally, it is going to take the very same time. Because on both scenarios, right, the only influence as far as acceleration along the vertical plane is the gravitational acceleration. All right, now let's look at B. Calculate the horizontal displacement of the shell. All right, for B, they want us to calculate the horizontal displacement of the shell. So that's the range, right? And as far as the range, by now you should know there's only one formula that we use along the range, right? SH, which is what they're looking for, is, what is this thing? Is UH times the time. Right, the time it took for the object to move from the top of the building, right, to its destination. Right, UH is given, it's 280. The time we just calculated, it's 3,194. So this would be 280 times 3,194, which is 894,32 seconds, not seconds, 32 meters. Right, are we getting the same thing?
Yes,
Same
sir.
on my side.
Right, that was pretty straightforward. C, the velocity when the shell hits the ground. Right, the velocity when the shell hits the ground. Right, they want us to calculate the velocity. Now with this one, right, they want us to calculate the velocity when the shell hits the ground. That velocity is this one. Right, remember that UH and VY, those are components of this velocity. Right, so when they ask you to calculate the velocity when the shell hits the ground, right, they are asking you to calculate the final velocity, which is this one, not the components. So they're asking for this final velocity, right, which is essentially a resultant of these two. So to calculate V, it's V, use Pythagoras. So this is UH squared plus VY squared. Very simple. Equal to, now you substitute. Right, UH is 280 squared. VY we calculated here, we got 31,305. So this is 31,305 squared. Now, obviously, if here you took this approach, then you'd have to first calculate the final velocity right here. You'd first have to calculate the final velocity, then calculate. You'd first have to calculate the final velocity along the vertical plane, and then calculate the actual final velocity just before the shell hits the ground. Right, so square root of 280 squared plus the 31,305 squared is, so I'm getting here 281,745 meters per second. Are we still together here?
Hello, sir. Can you
Yes.
just scroll up to how we got the 31.305? Okay, that's how we got it. We got it, sir. Thanks.
Any more questions? Hello?
Nothing from my side so far.
All right, let's look at D. All right, D, the velocity of the shell after 50 meters if the cannon is fired vertically upward. Right. See, now the scenario changes. Right, now they want us to calculate the velocity of the shell after 50 meters. So that's the final velocity, right? If the cannon is fired vertically upward. So in this scenario, we assume that the cannon is now being fired vertically upward. Right. Now this is being fired vertically upward. All right. So something like this. Right. This is let's do this. All right, this is going vertically upward. All right, that's going in that direction. All right. And then all right, this is 50 meters. So the height is 50 meters. Right. And then what else? So they do not mention the velocity of the shell after 50 meters if the cannon is fired vertically upward. Right. Now, they didn't say, did I even give us the 50? Oh, yeah, they did. Now, they didn't say that the 50 meters is the maximum height. Right. They just asked us to calculate the velocity of the cannon after 50 meters. Right. So we cannot assume that this here is the apex. right? It could happen that the canyon continued rising, right, after 50 meters, but they want us to calculate the final the velocity at this point, right? The velocity after 50 meters, right? Nothing in the statement suggests that the 50 meters is the maximum that the canyon rose, right? Or that the 50 meters is the apex, right? And then as far as initial velocity, right, that is 280 meters per second, right? Because all they did there is the velocity of the shell after 50 meters if the cannon is fired vertically upward, right? So all they did was essentially change the scenario, but the initial velocity remains the same, right? So the initial velocity, right, as soon as this cannon was fired, is still 280, or we are still going to assume it's 280. The only difference is that now this will be the initial velocity along the biplane, seeing that the scenario has changed. Right? And then because this is going up, it means G, right? G is negative 9.8 meters per second squared. Right? Now we don't have time, but we do have H. So the only kinematic equation we can use here is Vy squared is equal to Uy squared plus 2GH. Right? And then because G is negative, it means that will be negative. All right. We're looking for Vy, so Vy squared, Uy is 280 squared minus 2 into 9.8 into 50. So Vy squared is 280 squared minus 2 into 9.8 into 50, which is 77420, right? And then of course we are looking for Vy, not Vi squared. So to get Vy, use the square root on both sides. That's the square root of this. Square root of this is 278, comma 244 meters per second. Right.
Yeah.
Sorry.
I was just saying, I'm following, sir, nicely.
Okay. This is actually a very good question. Right. Any questions on D? No questions. Okay. So that was D. Right. E, calculate the time it would take the shell to fall a distance of 50 meters freely. Okay, this question we've already answered, if you think about it. All right, they want us to calculate the time it would take the shell to fall a distance of 50 meters freely. So remember that scenario I asked you about? That's exactly what they want us to do here. All right. So essentially, It means we are going to do the very same thing we did here. So just copy this, paste it here. Right, so remember we discussed that if this was freely falling, right, we would calculate it, or we take the very same approach, because whether it's freely falling or it has been projected horizontally, right, it takes the same time, the same time, right, to fall from the building to 50 meters from the building. Are we in agreement here?
In agreement, sir.
Yes, sir.
Right, so that one, essentially, we have already done. That's E. And then F, the velocity with which the shell would hit the ground if it were in free fall for 50 meters. Okay. So now they want us to calculate the final velocity, right? If this was freely falling from the top of this building, right, to after 50 meters, right? Yeah. So essentially we have this scenario. So this is the scenario, right? But this is now moving to the ground. So that's now moving in that direction. This is now moving to the ground. This is not that anymore. So the initial is at the top. This is freely falling from the building. So this is Uy. Uy is 0 meters per second. The G is going in the same direction as the motion, so it's positive now. So this is positive 9.8. The height is still the same. They are looking for the final velocity, right, before this hits the ground. Right, they're looking for the velocity before this hits the ground. So we're looking for Vy squared is equal to Uy squared. That's positive, so this remains positive 2gh. Right, so we're looking for V, so Vy squared, Uy is 0, 2 into 9.8 into 50. Right.
So I just have a question, sir.
Sorry?
The 50 doesn't that become 100 meter now? The 50 meter.
100 meters.
Yes, sir. I'm
From
just
when?
asking a question
Okay,
because
no.
can you
Because
just maybe reread it? Yes.
the velocity with which the shell
Oh, you were to free fall, yes, sir.
in a
Yes.
free fall of 50 meters.
Sorry, yes. I understand now, yes.
Yes. So the height is still 50 meters. Oh no, the height is still 50 meters. Right. So the right hand side of this is equal to 980. So this will be Vy squared is equal to 980. And then to get Vy, we find the square root of 980. Square root of 980 is 31,305 meters per second. All right, so if this were freely falling, right, if this were freely falling, this would be the velocity just before it hits the ground. Right. Any more questions? Yeah, we are done. Oh, yes. First one, 3,193. We got more or less the same. Second one is correct. C is correct. Yeah, C is correct. D. So they took a much longer approach. Hell no. But it is correct. That's correct. That's correct. All right. So if you look at D here, they used the quadratic equation, which is a much longer approach. I think our approach was much shorter. D, yes. Very simple. All right, straight to the point. All right, so with projectiles, right, just try to use the most convenient equation of motion. Right, if you can avoid having a long solution, right, try to avoid that by all means. If you look at what they did there for D and what we did, major difference, right, in terms of the steps they took, right, to getting to what we are looking for, right, so relative to the steps we took. Right, as much as it is correct, but always try to take the path of least resistance. Are we clear?
Yes, sir.
Yes, sir.
Right, now are there any more questions?
None from me, sir.
Right, with this, just like with any other unit or module, right, just work on your understanding. Right, what helps me is schematic illustrations. Schematic illustrations, right, they help a lot. They help a lot. Right, they solve like half the problem, because if you can tell, if you are able to draw a schematic illustration from what you've been given, right, it gives you context as to what steps to take towards finding the solution. Right, this here breaks down the problem. Right, so if you want to do well in engineering science, right, schematic illustrations must be your friend. Free body diagrams must be your friend. Right, if there is nothing else, we can end the session here.
Thank you, sir.
Nothing from me.
Okay.
Thank you, sir.
Sorry, sir. When is the next class?
Next class will be after your test.
I will not before. Not one more before.
One more before. What one more before? We have done all units. Relative, we have done resulting, we have now done projectiles.
Okay. Can you send it?
Unless you want me to add
Uh-uh.
the test.
No, don't add.
All right.
Can you post that in the group, please?
What exactly?
The
This
one
view?
that we did now.
Oh, okay, yeah, I'll do that.
Okay, thank you.
And then also, it's just attempt these ones on projectile motion. To see if you understood what we did here today. I'll send this in the group. It is on Moodle. Let's just see quickly. Yes, it is on Moodle. Right. So if you have access to Moodle, you can access this there. I will send the group though. And then I'll do a couple and then send the solutions to the group as well.
All right, sir.
All right. If there's nothing else, we are done.
Thank you. Toodles.
Study well, guys. Cheers.
Bye.